Greetings, everyone, and welcome back to Microsoft's Java for Beginners series. My name is Brian Benz, and I'm a cloud advocate at Microsoft. I'm joined by Oleg Šelajev. Oleg's going to tell us about Java testing. Oleg, do you want to introduce yourself and tell us about the topic?
Hi, everyone. Thank you, Brian. My name is Oleg, and I work for AtomicJar, which is a company created by the maintainers of Test Containers Java library, which is the integration testing library that is really, really good. Today, we're going to talk about unit tests and how you can write your first test for a Java application. We're going to introduce and look at the JUnit framework. And I think this is an essential skill for any developer, and hope you're going to learn the basics and then successfully apply that in your career. All right, what does it mean to write test and test our application? Our application consists of code and it's written in Java or any other JVM languages, but in a nutshell, this is the functionality that describes how our app needs to behave. Now, the tests for the functionality are also code, which is structured with a very precise purpose. We want to write code that verifies how our business logic, how our application works. For that, we need three essential things, which is set up the environment and assumptions. Then we need to run the app and we need to run the code and then verify the results. This is exactly what we want to do. And this is now we're going to write that in Java, and I'm going to show you how you can write your first test using the JUnit framework. Different languages sometimes include the SDK for writing unit tests in the base package. Java is not like that. Java does not have a library for writing tests included in the standard library. You need to include that separately. This gives you great flexibility for what library you want to choose. And we're going to go with the default one. This is a Maven project. So we're going to include the dependency on the JUnit library. JUnit is the name of the library that we're going to use in our pom.xml. If you want to learn more about Maven and build tools, please consult another video on this playlist. So we're going to have a dependency, and we're going to have a dependency on JUnit and the artifact called JUnit Jupyter, which is sort of the umbrella parent artifact for the JUnit dependencies that we need to pull. We're going to identify that we want to pull this only into the test scope, so only for the tests that will be included. But now we'll have access to the JUnit classes. In order to make Maven aware that we want to run tests, we need to include a plugin that will locate our test and run it as a part of the build lifecycle. For that, we include a plugin into the plugins management system, and we include the Maven Surefire plugin with a modern version. So that's going to go great, and they are both compatible, so we're going to run with this. Now, by convention, our tests will be located in a source test directory, and we're going to follow the same structure as the source main Java package name class name. We're going to have test Java source test Java package name application tests. Make sure that your class ends with test or tests. That is the convention for the Surefire plugin to find your tests and run them automatically. So any test class and any test method can be a test. So to turn that, we need to annotate that with a test annotation from JUnit. We're going to do exactly that. You can immediately see that my IDE figured out this is a test class, and now I can run this. So when I click play and I will run verify stuff works, what will happen is my IDE will build the class path of the project, and it will run the code in this particular test. If I would like to run that using the build tool, I can just run Maven test phase command in any terminal. So it will package my project, it will run the test, it will start using the Surefire plugin that we included. Let me show you. So it runs the Surefire JUnit platform provider for the tests, and it prints a little summary of the test results. Tests can be in several states. It found our one test that we want to run, and it says that it ran it and it ran successfully. So there could be a successful test run, a failure, which means that the assumptions of the test or assumptions about the behavior and verifying the results didn't work. An error, which means that the test broke, maybe through an unwanted exception or anything, or the test could be skipped. So we can run tests from the command line, or we can run tests from our IDE, whatever that is. You can run tests, and JUnit tests are the de facto standard in the Java ecosystem. So all IDEs will work. I'm running here in IntelliJ IDEA. You can run in VS Code, Eclipse IDE, NetBeans, or any browser IDE, whatever you want. Now we can run this test. Let's verify that our application works as expected. So setting up the environment is easy. We would like to create the objects that we want to kind of run code off, and then we can verify the behavior. So we can create the new app, and we're going to say that it has the offset of 0. It's going to be an app variable. Then what we can do, we can say app add, say 2 plus and 42, add two integers. This will produce a result that we can hear. Let's call it the result, actual result. And then what we need to do in a test, we need to verify that this results actually corresponds to our understanding what the app has to do. So say for expected value, or let's say int expected value is 42 for this particular use case. So now we would like to run something akin to the type if expected equals actual result, then sort of pass the test, and else we need to fail the test. And now failing the test means that we can throw an exception, which the Surefire plugin and the JUnit by default will consider a test in error. If our test just throws an unexpected exceptions, it might mean not just that the application didn't work as we expected, but it means that application got broken when we actually tried to use it. You can cover the the code pass, which throw exception with a little bit more advanced JUnit features, but for the initial first test that you want to run, you don't have to. So instead of verifying code like this, what we're going to use, the assertions library from JUnit itself. So we're going to say assertions, assert equals, and here we're going to have the expected outcome and the actual result. Now, the assertions will correspond to running with the test, and then if the assertion is actually correct, and you can have there are multiple methods. So assertions, you can see there assert equals, or assert true, or assert that the call throws, or assert false, all the good stuff. You can have a number of assertions in a test, but the first assertion that fails can fail the test. Let's see that. So first, we're going to see whether the expected and actual results are correct. Let's run this test. Let's verify stuff works. You can actually, here's the interesting thing. You can call your method name something more legible and readable. So for example, let's call it verify adding positive numbers works. Then in the test result, we would see a much more telling name here. So of course, our test doesn't pass. It throws the assertion error. It shows that a yellow marker in my IDE. It means that the test failed. And of course, why it failed, because when we add 2 and 42, we get 44. So let's change it to have the correct behavior. We could have changed the expected result and add the same, but we can also play with the parameters here. Right, now if we rerun this test, it will work. It will show us the green checkbox that our test works, and then it will run. It will work. We tried to rerun the test, but since we changed the name of the method, it didn't find the previous one. So the test works, the assertion passes. Very, very good. Now, JUnit is a very flexible framework, and you can create, of course, multiple test cases in the same class. And you can also run the multiple tests at the same time. So we can run app tests, or we can run with a command line using the Maven command, and it will run all the tests that it automatically discovers. You can configure everything, but you don't have to do that besides the basic things. Now, if you don't want every single test case to repeat setting up the environment, what you can do, you can specify the lifecycle methods for the tests, which are very, very convenient. So what we can do, we can say, we can mark a test with the lifecycle annotations, for example, before all or before each. And what we can do is we can create this static method that will do the setup for us. For example, we can say the app equals new app with the offset, and we can create the static field in this particular class. Now, the JUnit will execute our before all method before all the tests within the class, so we can only run one instance of this application. I can even show you. So if we go into the app and say change the code to say hello, creating an app with the offset and plus offset, and we can run the tests, we're going to see that only one instance of the app is created very early in this process, and it was just done. Now, in the tests again, what I can do, I can also create the environment for running the test before every test. So say I would have the private int n equals 0, doesn't matter. So and I'm going to do the n++ thing. So we're going to, all the time, we're going to create a new app. We're going to increment the offset. And then if we want to have it in the before each, we don't have actually the field to be static. So we can have the instance methods. I'm going to run now, and now we're going to create a new app for every test, incrementing the offset, and it will work beautifully, creating 2 apps. This is how you can build extensive test suites for your application. And in general, you want to test for multiple scenarios, for happy paths where everything works as expected, for unhappy paths where the arguments are less fortunate, for example, checking for nulls if you have nulls acceptable in your API, or you can do all kinds of tests to verify the behavior. Your IDE and your tooling will help on every step. You will be able to run your tests from your IDE. You will be able to verify and run your tests from your command app. So if we run the tests again, now I would expect Maven to find 2 tests and run them again. And that is how you write your unit tests for your Java application.
Thanks, Oleg. That was really great. Please check out the rest of the topics in Microsoft's Java for Beginners series.
Thank you.